Oops. Let's go over here. Whoops. Okay, so this is a problem about people that know they're murderers. Okay, and it says here, suppose that 64% of people murdered know they're murderers. Okay, so there's a problem about proportions, it looks like, 64%, right?
Right.
If there are 50 unsolved murders this year, find the chance that less than 60% of the victims knew their murderer. All right, so if this is a problem about proportions, then this must be something about sample proportions, I bet. And this 64%, does that sound like it's something that comes from a sample or from a population?
From a population.
Yeah, because it's 64% of all people that are murdered, right?
Right.
Okay, so that sounds like a population proportion. Now, if it's a population proportion, then I should draw this thing. Let's draw our p hat
Right.
distribution, and that looks something like that. And here's p hat over here. And that means that the 64% goes where?
In the middle.
Yeah, in the middle. So it's 0.64 there.
Right.
All right, so this is the p hat distribution, and this distribution shows you how the sample proportions fall each time if you take a sample and then actually compute the proportion of those people that knew their murderers, those people murdered that knew their murderers.
Right.
Now, suppose I want to find the chance that less than 60% of the victims knew their murderer in a sample of 50 unsolved murders. So this 50 up here represents what? What did we call that?
The sample.
Sample size, right?
Right.
So that's got to be n is equal to 50, right? So
Right.
that's a sample size. Now, if that's a sample size, then if I'm going to compute 60% of that sample, then that's going to give me a p hat, and if I graph the 60% as a p hat, it's where compared to this 64?
It's going to be towards the left.
To the left, okay.
Right.
So it's down here somewhere, right?
Right.
So let's put 0.60 down here. Now it's asking me to find the chance that less than 60% of the victims knew their murder. That means I'm looking for what area?
The area to the right. No, to the left.
Yeah, it says less, right?
Right.
Okay.
It says left.
Okay, so draw a line here, and let's shade the part to the left of 0.60, right?
Right.
So if I find that area, that'll give me the chance that I have a sample proportion from this 50 that's down below 60 or 60%. Now, how do I find that area right there?
Find the z-score.
Yeah, exactly.
Okay.
Okay, so let's draw a picture of our z distribution over here. So this is z. And when I get over here, what's in the middle of this z distribution?
0.
Yeah, that's 0. So that means what corresponds to this 0 over here for the z?
0.64.
Yeah, the thing in the middle from the p hat distribution, right?
Right.
So this 0.64 is going to be the same as the 0 over here. Now, how can I figure out what the z-score of that 0.60 is?
We do the formula.
Yeah, so it looks like it's going to be somewhere to the left of 0, right?
Right.
Because it is to the left over here. Now, is
Right.
that going to be a positive z-score or a negative z-score?
A negative z-score.
Yeah, because it's to the left of 0, right? So I'm interested in what that z-score is right there.
Right.
And then once I get that, what we'll do is we'll look at the area to the left of that z-score, right?
Right.
Okay, so now, how do I find the z-score?
Well, we do the formula, which is data value.
Okay, wait a minute. So it's going to be data value, data, minus what?
Minus the mean.
Yeah.
And then standard deviation on the
Oh,
left.
wow. Good. Okay. Now let's put in what we know. We know that the data is what for this z value?
Would be 0.64. Oh no, that's the population. The data.
No. That's the mean, right?
Oh, that's the mean.
Right.
Right. So then the data is the 50. The 60?
No, that's the sample size.
Right. Okay.
Yeah,
so
the
then
60.
It's the 60. Okay.
Yeah, you're right. That's at the data value minus the mean,
Minus the mean,
0.64.
which is 0.64.
Now, how do I get the standard deviation?
Well, we don't know it yet. Don't we?
No, we don't know it. You're right. And
exactly.
so what do we have to
that'd be
do?
X.
Hang on a minute. Oh, so we got to compute it. Hang on. Wait a
Okay.
minute. Standard deviation in this case is going to be,
Well, the formula.
which
so
is
would be population. Well, no.
theta. Let's write it
theta,
down. Okay, so
theta.
it's a square root. We need a square root.
Square root.
So it's going to be theta,
Theta
and then it's 1.
minus theta
Yes. And then on the bottom, it's what?
over n.
What's n?
The n is the
It's the sample size.
The sample size, right?
Right. So
Okay.
in this case, it's what?
50.
Yeah, right.
Right.
Okay. So
Okay.
here, so let's put in all this stuff. The theta's the thing in the middle, right?
Right.
All right, so that's that thing. So this is going to be square root.
Okay.
Now what goes in here for that is
So
0.64.
Right.
And now it's 1 minus 0.64, which is what?
Right.
Point.
1 minus 0.64. That would be 0.36.
Good. And then on the bottom, I have
50.
50. Okay, so altogether, are you ready with the calculator?
Right.
I need 0.64 times 0.36 divided by 50.
Okay, so we get 0.23.
Did you take a square root of it?
Oh no, I just did the top. Okay,
Okay,
so,
just the top. Divide by
okay,
50.
So divide by 50.
Okay, and now take a square root of it. You see the square root sign?
Right.
Not there. That's the square sign. Square root is that one.
Okay.
So tell me what you get.
So we get 0.067.
Yeah? 6.7. Okay. Good. Now let's put that in up here. 0.067. Okay. Now I need some more calculator magic. Let's do 0.60 minus 0.64. And now divide by 0.067. That's our z-value. What do you got?
Yeah, negative
Yeah?
0.59.
59. Okay, good. So that means that this z-value up here is negative 0.59.
Right.
Now, how do I look up the area to the left of that z-value?
We do table lookup?
Exactly. Okay. Now, you have a table?
Right.
Good.
Okay.
All right, so the area that we want is going to be table lookup. Wait a minute, let me write it. Table lookup. And then the z-value we need looked up is minus 0.59. So go over to first find minus 0.5, right?
Okay,
And then go over to where the 9 is.
Okay.
Yeah, that's it.
So then it would be 0.2776.
Yeah, 776. Okay.
Right.
So as a percent, that represents what?
27%. Or
Yeah.
around 28%.
Yeah, around 28%. So that means this area right here is about 28%, which means that this area over here is about 28%. And that means that the chance of getting less than 60% of the victims knowing their murderer in this sample of 50 that we started out with is about 28%.
Oh, okay.
Got it?
Yep.
Okay.